What questions you guys have today? What problems you'd like to go over?
Can we look at problems 4 and 7?
Okay. So we got 4, 7. Anything else, guys?
I was gonna ask to go over two, but I figured it out.
Okay, good enough. So we'll do 4, 7. All right. And any other questions you guys have, just feel free. All right.
Alright.
Okay. Now, question 4 is it's a tough problem. It is certainly not easy. All right. Now, before we do 4, though, all right, we have to do 2. Now, Austin said he had a question about 2, but he figured it out, which is great. But in order to do question 4, we have to be able to do question 2. All right. So I want to first start with question 2. Okay. Now, and I know you guys didn't ask about this, but it's a problem that I want to go over so that question 4 makes more sense. Okay. Now, as 6th graders, we learned how to find the area of a trapezoid using a method called deconstruction. Right? We would deconstruct or take apart the trapezoid. So I'm going to take apart this trapezoid as one rectangle and 2 triangles. All right. So we're going to deconstruct it. Now the reason why we have to deconstruct it is we're looking at a trapezoidal prism, meaning that we have a prism, but the bases are in the shape of a trapezoid. So we have to find that base area, which is in the form of a trapezoid, and then we just have to multiply that base area times the height. Now I think all of you can see that this blue rectangle is 4 by 3, so that blue rectangle is 12 12 square units. All right. And then we still have to find the area of the 2 triangles. Well, how do we do that? Well, here's what we do. If from here to here is 4, and from here to here, right, from here to here is 11, what's left over for this space and this space is the difference between the 11 and the 4, and the difference between 11 and 4 is 7. So we have 7 units left over for this distance here, these 2 distances, and if we split that 7 in half, that means that this segment has to be 3.5 and that segment has to be 3.5. To find the area of a triangle, we multiply 3.5, right, times the height, and we take 1/2. So if we do 3 times 3.5, that's going to be 10.5. Half of 10.5 is 5.25. So each of these triangles has an area of 5.25. So the capital B, or base area, is going to be the 12 plus 5.25 plus 5.25. So that base area is going to be equal to, what's that? 22.5 square meters, right? And that's what we would have learned as 6th graders to kind of deconstruct that trapezoid. So we find that base area is 22.5, and that's the hard part, because the easy part then is just to take the base area and multiply by the height, because volume is equal to the base area times the height, and we just found that the base area was 22.5. We see that the height is 4. Oops. So when we multiply 22.5 times 4, that's where we get the volume of 90, what is that? Cubic meters. All right. Now that's problem 2. In order to do problem 4, we have to use that same strategy, right? The same thing. Okay? So let's start with this piece here. Right? We have to find the base area. The base area consists of that rectangle and this trapezoid, right? That's your base area. The rectangle plus the trapezoid. So we know the rectangle is 5 by 3, so I know the rectangular part there is 15. But then we have the rectangular part of the trapezoid. I'll do it in green. That's 2 by 2. So I know that that's 4. And then we just have to find the triangular parts for the base area. Well, let's see. How do I find that? Well, if this is 2 and this is 5, that means that there's 3 left over between 5 and 2. So that means this length is 1.5 here, and 1.5 times 2. 1.5 times 2 is what? 3, and we take half. So that's 1.5. That's 1.5. All right, so that the base area is going to be 15 plus the 4 plus 1.5 plus 1.5. So that base area is going to be 19. 19 plus 3 is 22 square centimeters for the base area. So we have to find that base area first. And we kind of deconstruct that base, and we get 22 centimeters. And then we got to multiply by the height. And the height is 10. So volume is going to be equal to the base area times the height. That base area is 22. That height is 10. And that's where we get a volume of 220 cubic centimeters. All right, and that's where we get answer C for question 4. Right, that is a challenging problem for volume, without a doubt. But this is the third day of doing volume, and we want to try to do some of the other more difficult prisms. Okay. All right. Now, I don't know if you can see this clearly, right? But that's 1.5, and this is 1.5 for those areas, right? It's not 15, right? That's 1.5. Okay? And then the other question you said was 7, all right? So we'll take a look at 7. And don't worry, I'm going to post this video like I did with the other video. I'm just going to record these sessions, and it makes it a little bit easier for everybody if they don't get to it. Question 7. We're talking about a cereal box. A cereal box would be in the shape of a rectangular prism. So this is simply volume is going to be length times width times height, right? That's all that it is, because it's cereal boxes in the shape of a rectangular prism. So volume is going to be equal to the 14 times the 9 times the 3. So when we multiply 14 times 9 times 3, we wind up with, what's that, 378?
Yes.
And these are, oh, and this is the problem where I said to enter it without the units. So you would just leave it as 378, right? We know the units would be cubic inches, but if you're entering it in the, in the computer, you could put 378. I mean, you could put in the inches cubed, it doesn't matter, but, it would be 378. All right?
Can we also go over the answers for the other problems?
Sure. We can look at that. All right, question 1 we didn't go over, but question 1 is the triangular prism, right? And we're finding the volume of the triangular prism, right? So that should be D. And question 2 we didn't go over. Question 2, oh yeah, question 2 we did. All right, question 3 is the formula is the rectangular prism. So that's just length times width times height. So that would just be answer C. Problem 4 we did. Problem 5 will look like this. Problem 5 is another triangular prism. And just remember, with the triangular prisms, it's 1/2 base times height, right? And then times the height of the prism. So it's 1/2 of the product of these three numbers. And one of the mistakes that I'm seeing from your work is that kids are just forgetting to take the 1/2, which is a normal mistake, obviously, to forget to take the 1/2. So just be careful that when you have the triangular prism, you got to take the 1/2. And then problem 6, which we didn't go over, should be 13 inches. All right.
Okay.
Any other questions, guys, that we didn't go over, or that you're not sure about, or that you want to talk about?
Can we go over 1 and 2?
Absolutely. So let me go back to 1 and 2. Okay. And anybody that, yeah, no problem. Take care. Yeah.
You too.
Now, when we're doing the volume of the triangular prisms, right, just understand first of all that volume is the base area times the height, right? So we have to find the area of the base. Here's your base. It's in the shape of a triangle. To find the area of the triangle, we need the base of the triangle times the height of the triangle. And how do I find the base and the height? I have to look for that right angle symbol, because that right angle symbol will tell you what the base and what the height are. So I can see very clearly that the base of my triangle is 5. The height of my triangle is going to be that distance there. It's going to be the 13. So volume is going to be equal to 1/2 of 5 times 13, but then we still have to multiply by the height of the prism as it sits on the base. So we have to multiply it by that 13, that other 13. Right? So notice it's just 1/2 of the 5 times the 13 times the 13. So when we multiply 5 times 13 times 13 and we take 1/2, we wind up with 422.5, and our units are going to be cubic centimeters. Okay? And then you also said question 2. Question 2 we went over. Or were you not here, Leo, when we went over that?
I wasn't here.
Oh, all right. Well, my slide is all crazy here, but I'll go back. I'm going to do the problem the other way with you. With the other kids, I went in and we deconstructed. Here we're going to use the formula, right? So I'll do it a little differently. So we know that the area of the base is a trapezoid. So I need the formula for the area of the trapezoid. So area of a trapezoid is equal to 1/2 of the height of the trapezoid times B1 plus B2. That's a formula that we used last year as 6th graders. So that's my base area. So when I look for the volume, I have to find the base area times the height, but that base area is the trapezoid. So that's going to be 1/2. The H is the height of the trapezoid, so that's this segment here. That's going to be the 3. Oops. And then I need my B1 and B2. Here's my B1. Here's my B2. Your B1 and B2 have to be the parallel segments of the trapezoid. So that's going to be 4 plus 11. Right? You're adding your B1 and B2. And then you got to multiply that by the height of the prism. That's this segment here. Right? That other 4. So your volume is going to be equal to 1/2 times 1/2 times the 3 times the 4 plus 11 times the 4. So that's where we wind up with, when we multiply all that out, 90 cubic meters. Alright, so in the video we actually do the problem 2 different ways. Alright, and since you weren't here, Leo, you can go back and look at the video if you want and see how we did the problem the other way using deconstruction. But this is how you would use the formula to do problem number 2. Alright?
Okay, yeah.
Any other questions, guys? Anything else for today? Okay, tomorrow I'm just giving you guys no work tomorrow, or no written work anyway. You're just going to have to watch the video of finding the volume of a pyramid. I would strongly suggest, though, that you come here tomorrow and do the meet, because I actually do a little experiment or a little demonstration using different prisms when we do volume, so that would be kind of neat for you to watch if you want to do that. I would suggest that you come back tomorrow. Okay? All right, guys, if there aren't any other questions, I'll see you guys hopefully tomorrow, okay?
Alright.
All right.
Have a good day.
Take care, guys.
Thank you.
You're welcome.